My name's Grant Bugher, and I'm here from Microsoft to talk to you about the secure use of cloud storage. So a little background on myself. I work at Microsoft in online services, security, and compliance. So I work with the product development teams that are creating Microsoft sites and services and help them to develop secure software and securely deploy their infrastructure. And just as throughout all of industry, teams at Microsoft are considering using cloud services, and Microsoft has its own cloud offering as well, Windows Azure. And so I've been pretty heavily involved in that lately. So I'm going to talk about a couple of cloud storage systems and applications written against them. So the two I'm going to be discussing are the Microsoft Windows Azure platform and the Amazon Web Services platform, as they're both mature cloud storage platforms which are being used by companies today. They also have well-documented interfaces and are good for doing research on. So I'm also going to do a bit of a talk about database attacks on cloud-based applications and walk through how people carry out injection attacks on a cloud-based app. And then I'll move into defenses and mitigations. How can you develop your software to not be subject to these attacks? And how can you design more secure applications for the cloud in general? So really, this information could be useful to software designers, architects, testers, anybody who is designing, building, and deploying applications. I'm really focused on the development side, writing new applications for the cloud, and want to help you understand the security challenges and the recommended approaches to designing and developing more secure apps in the cloud. So cloud storage systems. The purpose of these systems is to move the application database layer to the cloud. So rather than running your own databases as your backend, you can use a cloud storage platform run by someone else as the database backend. And you can actually use a cloud storage system regardless of if you are writing a cloud application. You could host your storage layer with Microsoft or Amazon while still running your own app, or running your app on traditional hosting rather than actually hosting your app in a cloud system. The storage layer is actually separate from the processing layer. Cloud storage promises very high performance, scalability, and availability. It's the reason people use it. You can store enormous amounts of data, pay only for what you're storing, and have the performance remain constant as the amount of data increases. Cloud storage systems are designed to handle a variety of types of data, including blobs, tabular data, queues, and even relational databases. And I'll be talking about how Amazon and Windows Azure handle each of those data types. So whoops, I think I went the wrong way. No, okay. So the Microsoft Windows Azure platform has two storage services. The Windows Azure Storage Service, which is divided into a blob service, a table service, and a queue service, and SQL Azure, which is a relational database in the cloud. Amazon Web Services has the Simple Storage Service, which is a type of blob storage, SimpleDB, which is tabular data roughly akin to what the Azure Table Service provides, and the Relational Database Service, which once again is relational database hosting in the cloud. So the Windows Azure Blob Service is designed to handle large arbitrary binary objects. They don't actually necessarily have to be large. You could store images, style sheets. Pretty much any single block of data can be stored in the Blob Service. They are designated by a container name and a blob name, which are roughly akin to a folder and file name. Containers can be very large, and the containers and blobs can have associated metadata. So not only are you storing the blob, you can attach metadata to it, which can either be things like the date it was uploaded and such, which are added automatically by the platform, or you can add arbitrary metadata to blobs just for your own use in indexing and finding them. Containers can be public or private. If they're public, anyone can access them. And actually, if they're public, it's possible to access them directly in a browser. So you can, for instance, host your static content from a website, the images and style sheets, and have people download it straight out of the cloud provider and not pass through your server at all for that static content. In addition, public blobs are supported by the Windows Azure Content Delivery Network, so they have a worldwide set of servers for distributing these. Blobs in private containers require what's called a shared access signature to access. So essentially, your request needs to be signed in order for you to get anything out of the private container. Generally, these are used as back-end storage by applications rather than having end users access them directly. But actually, I'll be going through some scenarios where you do want end users to directly access side containers. The general API is a REST API, representational state transfer. So essentially, it's stateless. You make a call to it with a URL and some attached headers, and it sends back the blob. The Azure Table Service is designed to handle arbitrarily formatted tabular data. So it's kind of interesting. People refer to it as a table, but it's not like the tables you're used to from a relational database, because each row has a series of named properties, and there's no requirement that the rows in a single table have the same properties. So you could actually have different columns on every row in the table. And it's not storing empty values for other columns. Those columns don't exist. The set of properties is actually a property of each row and not of the table. A table can be very large. It can hold billions of rows, terabytes of data, but they are not relational. There is no concept of a foreign key constraint in the Azure Table Service. The only constraint is the uniqueness constraint on the key to each row. The table service is managed and accessed through an XML-based REST API. Special headers are required, though, so you can't access Azure Table Storage in a browser the way you could the blob service. It's genuinely meant to be an application's data backend and not accessed directly by end users. In addition to the REST API, Microsoft provides a WCF Data Services API for ASP.NET developers to access it in a familiar way. And that has some security advantages as well that I'll get into. The Azure Queue service is kind of interesting because it's not what people normally think of as storage. It's a queue of very short binary messages. They're limited to 4K each. And you have APIs to put a message in or to mask or remove a message from it. What this is actually for is when you are hosting your entire app in the cloud, and so you have an arbitrary number of nodes all running your app, and they need to communicate with each other. You can use this. You can use a common queue among all of them and have this do messaging between them. Once again, it's a REST API. Special headers are required. You can't access it in a browser. And it's not intended for storing data at rest. It's meant for communication. In fact, by default, after 7 days, messages expire and just go away if you haven't taken them out. Finally, SQL Azure is a true relational database service in the cloud. It's based on Microsoft SQL Server 2008. It's accessed just like SQL Server 2008 with the tabular data stream protocol, which is the protocol on TCP 1433 that all SQL servers use. It supports tables, indexes, views, stored procedures, constraints, triggers, most of the things you'd expect from a SQL database. About the only things you don't get are the service broker, SQL reporting services, SQL analysis services, and the distributed transaction coordinator, because the distribution and clustering is under the control of the service and not you as the developer. You can use any Microsoft SQL Server client library to access this. You can even use the SQL Server client tools like Management Studio and Visual Studio. So moving on to Amazon's web services, S3 is the simple storage service. It stores arbitrary binary objects. They're referred to as objects and the containers as buckets, so there's different terminology. But once again, the objects can be very large. They have associated metadata. You can make them public or private. And objects in public buckets can be accessed with a browser. And public objects are supported by a content delivery network, which Amazon calls CloudFront. SimpleDB is a table service. Stores arbitrarily formatted tabular data. Once again, very large amounts of it, terabytes of size in a single table. They are not relational, and they are, once again, a property with a series of named attributes. So each row in the table, they're referred to as entities, has a series of named attributes, and there's no reason you couldn't have every row have different attributes in a table. Really, both this and the Azure Table Service are referred to as table services because that's the primary use people have for them. Just because you can put different properties on each row doesn't mean people usually do. It's usually used to represent tabular data. Amazon's table service can be managed and accessed through REST or SOAP APIs. The REST API is potentially accessible from a browser. The SimpleDB requests can actually be condensed into just a URL. So unlike with Azure Table Service where you have to specify custom headers, with SimpleDB you could in theory get it out of a browser. That's just not the intended use of the service. They provide Java and .NET SDK binaries for easy access, as well as a WSDL for a SOAP API, so that if you have any SOAP toolkits or Visual Studio or whatnot, you can import the WSDL and create your own interface classes. The relational database service, it's a true relational database service in the cloud. Amazon's is based on MySQL. And it has full support for the standard MySQL features. It uses MySQL's client-server protocol, and you can use the standard Windows or Linux MySQL libraries to access it. It's pretty much indistinguishable. Both SQL Azure and the Amazon Relational Database Service are functionally identical to standard non-cloud database hosting. So as a result, I won't be talking much more about those in this presentation, as the security risks with those are pretty much the same as you would get from any SQL-based backend. So injection attacks. Injection attacks are the most common threat we see against databases in the online services world. Injection attacks, the most common is SQL injection, of course, where you put in some data that gets parsed into a SQL string and sent to the database and executed. The database layer, though, in traditional hosting is not generally exposed to the internet. The database layer is somewhere on the back end where only your app can reach it. In the cloud services world, this actually isn't true. Your database layer is sitting on the internet. However, if your access control is set up properly, it should be just as inaccessible to an attacker as it would be in the back end. It requires cryptography and so on to actually access. So your main way of attacking the database layer is still via carefully crafted malicious input, something that looks like data to the application, but is executed as instructions by the database. Rather than SQL, most of the injection attacks we can try to come up with on a cloud service are actually based on XML and their REST APIs instead. So XML and XPATH injection. Everybody's probably familiar with SQL injection, but XML data and XPath queries are also subject to an injection attack. It's the same issue as with SQL, fundamentally. It's a form of mixed code and data. XML contains both the data values, but also what data items and schema that they go into. And XPath contains both the query structure that tells where you're looking, as well as the actual items you're looking for. So if these are constructed from strings, you potentially get the same risks for injection attacks. On the bright side, with XML data, they often use smart serializers. People often don't construct their XML from strings. Rather, they use an existing XML serializer class, which hopefully has been better tested against these sorts of attacks, but not always. Unfortunately, with REST interfaces, they're so simple that especially on smaller, simple applications, developers do sometimes construct XML from strings, rather than going through the overhead of using an XML serializer. So there are two basic kinds of XML parsers, SAX parsers and DOM parsers. So SAX is the simple API for XML. It's a unidirectional event-driven stream parser. That is, it starts at the beginning of the XML file, reads each node one at a time, beginning to end. It's very fast, low-memory serial processing. The memory requirements don't grow with the size of the XML file. And it interprets objects as it goes along. There are not really any standards for the behavior of a SAX parser. The Java parser is considered normative. Whatever the Java parser does, that's pretty much what people think a SAX parser should do. DOM parsers, on the other hand, construct a full in-memory representation of the XML document. So they create objects to match with all these nodes and values. It takes more memory, and the advantage, though, is it's fast for random access. With a SAX parser, you have to do everything you're doing with the XML file as you go along. With a DOM parser, once you've loaded the DOM, you can access anywhere in the XML file very quickly. It allows random access to nodes. The thing